Hello, class, and good day. Welcome back to your ESI 124 and your Engineering Mechanics 2, or your Dynamics of Rigid Bodies. And for today's lecture video, we are going to talk about the part 2 of the lesson 7, the kinetics of a particle, work, and energy. And previously, we discussed the part 1, no? Part 1 lang, ng lesson 7, and we discussed there the um, what do you call the work of force, principle of work and energy, and principle of work and energy for a system of particles. Actually, we explained the concept and principle of work and energy and its application if system of particles na siya. And also, we solved some problems, no? Solve tayo ng mga problems related to work and energy. And with this, we determine na yung pagkuha ng work is just the product of the force times the displacement cosine theta if that force is constant, no? And also determine the work of weight, which is negative W delta Y, also with the spring force, which is negative F negative force times tapos from that we further derive the simplest formula to solve the work of the spring force, which is negative 1/2 times K times S sub 2 squared minus S sub 1 squared, no? That's for your spring force. And we also discuss the principle of work and energy, which states that the particle's initial kinetic energy, which is your T sub 1, plus the work done by all of the forces acting on the particle as it moves from its initial to its final position, which is the summation of U sub 1 to 2, is equals to the final kinetic energy of the particle. So, silly, yun lang yung mga diniscuss natin, tapos nag-solve tayo ng problem related to those topics. And yun nga, the lesson contents for today is the part 2 ng lesson 7, which is the power and efficiency, conservative forces and potential energy, and your conservation of energy. I think most of these topics are kind of familiar na, no, sa inyong mga previous lessons sa ibang subjects. But anyways, the learning outcomes for today is discuss the importance, kung gaano importante yung bakit kailangan natin malaman yung power and efficiency, no? Identify conservative forces and potential energy. Ano ba itong mga conservative forces na to and potential energy? And we're going to explain the concept of conservation of energy. And hindi mawawala, magsusolve din tayo ng problems related sa power and efficiency and conservation of energy. Yun lang. So, let's start for the power and efficiency. Ano ba itong power and efficiency? So, power and efficiency calculation are very important, no? Since it provides a useful basis, no? Basehan siya, no? To choose the type of motor or machine na equal or required to do a certain amount of work in a given time. For example, papipiliin kayo ng dalawang pump, no? To empty a reservoir if given enough time, no? So, para silang enough given na time, no? Magkakatalo na lang dito is yung power talaga nila, no? Kung saan yung malaki, mas better kasi nga yung mas malaki na power, makakomplete mo yung job sooner than the lesser one, di ba? But we should also consider, meron din tayo na downside dito. Kasi nga, if malaki yung power, it means mahal din siya, no? Yung economic side din ng pagpipili natin ng pump. So, to be safe na lang, pipili kayo ng pump na feasible for that pumping operation. So, ganun na lang, no? Kung ano yung feasible na kailangan natin gamitin, provided na alam natin ng power, tsaka ano yung dapat na ano yung operation na dapat nating i-complete, no, with given na feasible yung ginagawa natin. So ganun lang. Basta yung ang thought lang dito is that power, if malaki yung power, mas madaling gawin yung work in amount of time, no? Mas madali, uh, mas maraming work na ma-complete mo, mas mabilis kung mas malaki yung power mo, no? Okay? So power generated by machine or engine is equal to the amount of work power generated by the machine, your engine, is equal to the amount of work du it performs within a certain time interval dt. Thus, formula is equals to P is equals to d over dt. Yun lang. Nakasimple yung power, no? If the work du is expressed as du is equals to f dot dr, then this one will change to this one, di ba? Subject lang natin yung value ng du, which is f dot dr, no? So that will be f dot dr over dt. So therefore, we can change that to p is equals to f dot times v. F dot v. Yan lang. So, pwede kayong gumamit ng work or pwede din tayo gumamit ng work tsaka time. At pwede natin i-compute also yung power natin by force times the velocity of the machine or engine, no? Or yung work talaga na ano natin na displace within a given time interval. So, ganun lang. Pwede natin gamitin yung work tsaka time or force tsaka velocity to compute for our power. So, your P is equals to power, no? Scalar quantity, watts or horsepower. Pwede din yan. Velocity is meters per second or feet per second. That's your velocity. F is the force acting on the particle Newton or foot pound, no? Pwede ganun din yan. Okay? So, note that the following conversion factors, no? Meron kasi mga problems na i-require or hahanapan ka ng watts, pero yung given is horsepower or foot-pound, mga gano'n. Okay? So, you also need to familiarize this conversion factors. No? So, 1 watts is equal to 1 joules per second or equal to Newton meter per second. Pwede din yung 1 HP is equal to 550 foot-pound per second. So, 550 foot-pound per second is equal to 1 HP. And 1 HP to watts is 1 HP is equal to 746 watts or 0.746 kilowatts. So, pwede na din to. This is very basic na lang. So, kali, ayun. So, familiarize na lang itong mga conversion factors para sa application natin later, no? Okay. So, what about the efficiency? So, mechanical efficiency, yan, epsilon, of a machine is defined as the ratio of the output of useful work produced by the machine to the input of the power supply to the machine. That is, no, is equals to the power output, the ratio of power output, ayan, by the machine to the input of power supply. So, output over input na lang siya. So, that will be P sub O is over P sub I. So, this is output over input na lang, no? If we are talking efficiency. Now, if energy naman, yung sinupply natin sa machine and occurs during the same time interval at which it is drawn, so then the efficiency can also be expressed in terms of the ratio, ganito. So, energy output or energy input. So, pwede siyang power or pwede din siyang energy. Okay? So, output over input na lang siya. So, medyo basic lang yung efficiency, di ba? So, since machines consist of series of moving parts in which machine, transmission system, no? Mga transmission system natin sa machine natin. So, marami talagang moving parts na andon, no? So, frictional forces will always be developed within the machine, no? And as a result, extra energy or power is needed to overcome these forces. So, mas maraming moving parts, mas marami din yung machine na dapat i-overcome, no? Para makagawa ng work. So, note that the power output is less than the power input. No? Kailangan talaga Like, sa daming reductions na magaganap within the system. So, hindi talaga sure na efficiency mo is, or hindi talaga magiging 100% kasi may mga reduction, no, throughout the system. Yung input mo, i uh, hanggang sa output, hindi talaga equal. So, it should be always, no, always less than the power input. So, yung mga efficiency natin ngayon is less than 1 lang talaga, no? Which is, no, efficiency is less than 1 or 100%. So, always less than 1 yung ano natin. But in percent, always less than 100, no? So, that's your efficiency. Okay? So, procedure for analysis, para guide lang siya to solve for this power and efficiency. Now, identify the given amounts or required in the problem. That's, first talaga yan. So, determine the external forces acting on the rigid body, which causes the motion. So, kailangan din natin i-account yung mga external forces na dapat nating alamin. So that, wala talaga kulang, no, when we are talking about power and efficiency. So it is usually developed by a machine or engine places either within or external to the body. So yun. So mga talaga internally or externally dapat natin talaga may consider or ganun. So if the body is accelerating, it is necessary to draw its free body diagram and kinetic diagram and apply the equation of motion. All forces, no, is equals to mass times acceleration. Sum of all the forces is equals to mass times acceleration to determine the force F, no. So yun. So kailangan din natin i-draw yung free body diagram niya tsaka kinetic diagram so that we all know the magnitude of the force and the direction of it, no? So, kailangan natin ng FBD para ma-account or ma-visualize natin yung mga forces na andun sa object or body natin. No? So, if the force F or resultant external forces acting on a body or particle and its velocity V is given or solved, the power P can be determined using this formula. Ayun nga, pwede siyang ma-solve using the force and the velocity of the object or the particle. That will be P is equals to F times dr over dt. This is dt, not dr. Okay? The over dt is equals to f dot v. Okay? So this is how you compute for pure power in terms of force and its velocity. Okay? So that will be p is equals to fb cosine theta. So ganun lang yung pag-solve ng power mo. So that would, kung meron kang force siya velocity, multiply na mo lang ng kasi meron talaga mga forces na hindi talaga like same direction same direction ng velocity. Meron din mga inclinations, mga ganun. So, we need to consider that also. Okay? That FV cosine theta will be your talaga, no? Para siyang what they call this? Basihan, no? To compute for the power. So also using for the work or end time, so you can use this also. U over T. Okay, kung meron kang work tsaka time, then divide mo lang yung dalawa. Denominator mo yung time, so you can have your power also. And for the average power, you can have your delta U over delta T. Okay? So let's apply, no? Let's have an example. So the man shown in the figure pushes on the 50 kilogram crate with a force of F is equals to 150 Newton. Determine the power supplied by the man when T is equals to 4 seconds. The coefficient of friction between the floor and the crate is mu sub k is equals to 0.2, and initially the crate is at rest, not crate. This is crate is at rest. Okay? So kailangan nating alamin kung ano yung power na sinupply ng man so that ma-push natin yung crate na kailangan niyang i-move. Okay? So, kailangan natin yung power. So, given, meron siyang mass sa crate which is 50 kilograms. 150 Newton naman yung constant force na apply ng man natin. And the time is 4 seconds and the coefficient of friction is equals to 0.2. Okay? So, power supplied by the man, yung record natin dito, when t is equals to 4 seconds. No? So, draw the free body diagram to show all the forces and reaction acting on the crate. So, hindi tayo focus sa man kasi siya lang yung nag-apply ng force. Dapat, yung in-applyan ng force natin, dapat nating i-draw ng free body diagram. Kasi yun yung kailangan natin alamin, no? Kasi nga, dun manggagaling yung mga figures para malaman natin yung power na kailangan ng man. So that it can be Okay, so draw the free body diagram to show all the forces and reactions acting on the crate and apply equations of motion. Ayan, so meron tayong force na in-apply ng man, meron tayong weight ng crate, tsaka normal force because of the weight, tas yung friction force. Kasi meron tayong interaction between the floor and the crate. So to solve the input power or power supplied P sub I, we must first solve the velocity as the 150 Newton force is applied on the crate. So kailangan natin yung velocity. So let's solve that one. So all forces along Y, or summation of all the forces along Y is equals to M times the vertical component of the accelerations, which is equals to 0 kasi walang motion na nagaganap sa Y component natin, no? So that will be yung normal force, yung mga upward for mga vertical component ng mga force natin. This is the weight, normal force, tsaka normal force, and the force applied by the man, its vertical component. So normal force, positive yung natin pa upward. Okay? So that will be positive N minus or negative force kasi nga paano siya pa downward. But the vertical component, that will be 3 over 5. Okay? So minus 3 over 5 F minus work. Negative yung work kasi nga pa downwarded. Which equals to M sub C, or the mass of the crate, times 0, which is equals to 0. So the first, or the normal force na exert sa crate natin is equals to 3/5 of 150 plus 50 kilograms times 9.81 m per second squared. This is your weight, no? Lang natin, transpose lang natin itong dalawang terms sa right, so that magiging positive silang lahat, and matitira dito yung natin, which is your N. So your N now is equals to 580.5 Newton. Okay? So that's your normal. So let's also have the horizontal forces. So summation of all the forces along X is equals to M times A sub X. That will be your force applied by the man and the friction force, no? Yun lang yung Okay, so that will be 4/5 of force minus F sub F is equals to MC, or M sub C, times acceleration. That will be 4/5 of force minus friction force is equals to mass of the crate times acceleration. So that will be 120. Okay, so 150 times 4/5 is 120 minus 0.2. That's your coefficient of friction, no? Times the normal, kasi yun yung pagkuha ng friction force natin. That's your mu sub k times n. Okay? That will be 0.2 times 580.5. Then na-compute natin dito, which is your normal force is equals to 50 times acceleration. So your acceleration now of the crate is equals to 0.078 meters per second squared. So that we can now solve for the velocity. So since the applied force 150 and the mass crate are constant, and the computed acceleration A is also constant, no? So we can apply the kinematic constant acceleration equation, this one, so we can solve for the velocity of the crate. Therefore, that will be your V sub O is 0 since it is initially at rest. Your time is 4 seconds, and A sub C is na-solve natin is 0.078 meters per second squared, and that is constant all throughout the displacement. So that will be V is equals to 0 plus 0.078 meters per second squared times 4 seconds. Therefore, your velocity is equals to 0.312 meters per second. Thus, P is equals to 4 force times the velocity, which is your force should be the vertical component. Okay? Vertical component siya kasi yun yung basehan natin ng power, no? Bali ito yung magsisignify sa kumbaga, para siyang component ng force natin in vertical, in horizontal manner. So we can calculate the power of the man na in-apply ng crate kasi nga nag-move yung crate natin horizontally. Hindi naman siya paganto din yung direction ng crate natin. So medyo talaga. So we should consider account the horizontal component of the force only. Okay? Dapat i-note nyo to Dapat natin is F sub x V or the vertical yung horizontal movement, horizontal component of the force. Kasi nga doon din yung movement niya. Okay? So dapat natin i-align with the velocity. Okay? So that would be 4/5 of the force. That's your F of x or F sub x. 4/5 times force times velocity. That will be 4/5, 150 Newton. 4/5 times 150 Newton times 0.312 meters per second. So therefore, your power is equals 37.44 watts. Kasi nga, Newton meter per second is watts. Okay? So that's how you solve for your power. Alright? Just take note na yung pag-compute ng power natin is force times velocity. Okay? But also, we can solve this, no? We can also solve this by, to compute the work, tsaka meron naman tayong time, then you can solve also for the power using the work, no? Kasi meron tayong force, tsaka displacement, so meron talagang work na nagaganap. And then we divide that by 4 seconds, then we can have our power. But, eto nga, mas consider natin yung forces, vertical, tsaka component, horizontal, and then we come up for this one. Okay? So that's how you solve for your power. So, nyo lang, take note nyo lang yung formula ng power, yung kinematic acceleration equation, okay? So, dapat remember nyo pa yun. Okay? So, that's how you solve for the power. Okay? Let's proceed for the second topic, which is your conservative forces and potential energy. Ano ba itong mga conservative forces and potential energy, sir? So, conservative forces are those forces whose work is independent of the path and depends only on its initial and final position on the path. So, hindi siya mag-care kung asan yung magde-displace yung mo or saan ba patutungo yung yung object mo, no? So basta i-account lang natin yung initial tsaka final position niya, okay? So best example is the weight and the spring force kasi nga yung let's say for example na yung crate or say box mo, pinush mo horizontally, then yung work mo is your work, yung weight mo is a conservative force kasi hindi siya nagdedepende sa path ng mo, which is ang importante lang is initial tsaka final position ng weight mo. And of course, same thing with the spring force kasi nga yung path yung initial tsaka final position, hindi na siya nagki-care sa path ng object mo kung saan ba pupunta. Okay? So basta keep in mind na conservative forces are independent sa path mismo. Okay? But you should also take note for their initial and final position so that pag compute mo ng mga work or power tsaka energy niya, hindi kayo ma-confuse. Again, conservative forces are independent or forces whose work is independent. Okay? Yung work niya is independent sa path. Makakompute ka pa rin ng work niya kahit hindi mo binabasa sa path niya. Okay? So that's your conservative forces. So the work done by the weight depends only on the vertical displacement of the weight as shown in the figure. Ayun nga. So yung path ng natin, particle is pa right or pa positive or pa negative z-axis or basta papuntang likod ng screen. Okay? So but yung weight mo, meron siyang work na or yung work niya, meron siyang work, makakompute pa rin natin yung work kahit hindi tayo nagdedepende sa direction or yung path niya ng particle kasi nga meron siyang initial tsaka final position. Yun lang yung important sa kanya. Okay? Your final and initial, that will be your S sub 2 minus S sub 1. So you can compute for your work sa weight. Okay? Work ng weight hindi talaga yung weight mismo. Work ng weight. Okay? So that's your conservative forces. Independent sa path. Yung work niya. Okay? And the work done by the spring force as shown in the figure depends only on the spring's elongation or compression. So, ganoon lang. Doon lang siya magdedepende, hindi sa path ng mo. Okay? So, that's your, for your spring force. Bakit siya consider as conservative forces also. Okay? In contrast to conservative force, consider the force of the friction F sub F exerted on the sliding object by a fixed surface. So, yung friction force naman, in contrast sa conservative, kailangan yung friction force or force of the friction exerted on the sliding object by a fixed surface, the work done by the frictional force depends on the path. Okay? The longer the path, the greater the work. Kasi nga, nagdedepende nga siya. Okay? So, yung mas longer yung path mo, mas maraming ma-accumulate na friction force kasi iba-iba talaga every path na nadadaanan ng ng object or your object. So the longer the path, the greater the work sa frictional force. Okay? So ayun, hindi siya considered as conservative force yung frictional force kasi nga the longer the path, the greater the work. Okay? The greater the work of the friction force. Okay? Dapat mamunod nun. So, thus, the frictional forces are also called as non-conservative forces. So, yung mga non-conservative natin, yun yung mga dependent na sa path ng object natin. So, lang. So, the work is dissipated from the body in the form of heat. Okay? So, yun lang. Yung conservative again, and dependent sa path. And non-conservative, the opposite, which is dependent sa path. So how about the energy? So energy is defined as the ability or capacity for doing work. So yun yung energy mo The ability ng object or capacity of the object for doing work. Okay? So we will be dealing with the two types of energy here. We have kinetic, tsaka yung potential. Although we already discussed the kinetic energy, which is equals to 1/2 of mv squared. Okay, that's your kinetic energy. Yung T mo, T. Okay, so meron na siyang pair yung potential energy mo. When we are talking about energy, etong tayo sa sa topic na to, dalawa yung consider natin ng energy. Although maraming types of energy, but in here sa mechanics or kinetics of particle, dalawa yung i-consider natin dito, yung kinetic energy tsaka yung potential energy. Okay? So for kinetic energy, consider a particle or body that is originally at rest. If let's for example, a ball, at rest yung ball mo, then the principle of work of energy states that all or summation of the work by all the forces equals to T2 since T sub 2, since the initial velocity is 0, so note that T is equals to mv squared over 2 or 1/2 mv squared. So if 0 yung velocity mo, 0 din yung kinetic energy mo initially. Okay? Or the first or initial position mo. Okay? So yung at rest po yung ball mo, you can say na yung initial kinetic energy niya is 0 kasi wala siyang velocity or hindi siya nag-move, no? Kasi nga at rest. So yung principle ng work tsaka energy, no? Nung na-discuss natin, principle of work and energy na formula is, sum of the initial kinetic energy and the work or ayun nga, summation of all work done by all the forces of the object is, ayun nga, equal siya sa final kinetic energy. Now, for the ball na originally at rest, ito yung formula na gagamitin mo. Okay? Ito lang yun. Kasi nga, zero yung initial kinetic energy mo. Okay? So, that is for kinetic energy. So, in other words, kinetic energy is equal to the work that must be done on the particle to bring it from a state of rest to a speed v. So, yon. So, kinetic energy daw is equal to the work that must be done on the particle to bring it from the state of rest to a speed v. Okay? So, yan nga yung kinetic energy mo. So, wala siya kinetic energy if your particle is at rest. Okay? Kailangan natin yung work para ma-push or ma-obtain natin yung speed v so that meron tayong kinetic energy. Okay? So, thus, the kinetic energy is a measure of particle's capacity to do work which is associated with the motion of the particle. Ayun nga. So, when we say kinetic, it involves motion. Okay, ganun lang kasimple yung analysis dito. Kinetic energy is concerned with the motion of the particle. So, walang kinetic energy kung walang motion sa particle. Okay? So, kinetic energy is a measure of the particle's capacity to do work which is associated with the motion of the particle. So, capacity ng particle mo to do work so that it will, have the motion. No? It will create a motion. So, yun yung kinetic energy mo. So, when energy comes from the position of the particle, measured from a fixed reference plane, it is called the potential energy. Okay? So, yung potential energy naman, magdedepende naman sa fixed reference plane mo. Okay? And always siya dependent sa position mo. Okay? So, when energy comes from a position of the particle, measured from a fixed reference plane, that is what you call another type of energy here, which is the potential energy. Okay? So, meron pa yung maano dyan. So, thus, potential energy is a measure of the amount of work of conservative force will do when it moves from a given position to the datum or reference plane. Okay? Measure siya na amount of work of a conservative force will do when it moves from a given position to the datum or reference plane. So, in mechanics, potential energy is created by gravity or weight and elastic spring. So, kumbaga, yung potential energy mo is mostly, dominated by conservative forces. Just like the weight, tsaka yung elastic spring, which is we mentioned kanina. Okay? So, meron tayong tinatawag na potential energy. So, consider a particle shown in the figure which is located in the three different positions, yung position 1, position 2, position 3, or I don't know, nasan yung gusto nyong i-position dyan. Basta, yung meron tayong datum line or reference line. Okay? So, automatic, yung sa gitna, or itong or pangalawang natin, position is 0 kasi nga nasa sa datum line. So, wala pa siyang y or delta y kasi nga nandun sa origin or datum or ayun nga. So, if the particle is located a distance positive y, ito sa itaas above an arbitrarily selected datum or reference line, its weight W has a positive gravitational potential energy, V sub G, since W has the capacity of doing positive work when the particle is moved back down to the datum. Okay? Move back to the datum. So, kung papunta siya sa datum natin, positive yon. If away from our datum, that will be negative. Yun lang. Okay? Again, positive yung potential energy natin or gravitational energy. Positive siya kasi nga, nasa ibabaw ng datum line, therefore, due to gravity, magpo-fall down siya pabalik sa datum line mo. Okay? So, that will be positive. So, kumbaga, dalawang point of view. Ayun. yung datum line, kung above siya, that will be positive, below siya, negative. Meron din tayong another point of view, kung if pabalik sa datum line mo, that will be positive. If away or palayo, okay? Or, yan nga, moving away from your datum line, that will be negative, okay? So, likewise, if the particle is located at a distance negative y below the datum or reference line, v sub g is negative, since the weight does negative work when the particle is moved back up to the datum. Okay? Move back up. Ano yun? Move back up. Basta, ito pang if we are going to, diba? So, basta negative yung, a potential energy since the weight does negative work when the particle is moved back up to the datum. Okay? Ayun nga. Kumbaga, if ipupunta tayo sa datum line natin, yung weight natin is ayun nga, puntang down, oo, ano ba to? Pa-downward, okay? Pa-downward. Tapos yung, natin is pa-upward. Kasi if we move back to our datum line, opposite siya sa weight natin, which is downward. Kasi nga, if we move this back up to the datum line, magiging opposite na siya sa direksyon ng weight mo. Unlike dito sa ibabaw ng datum line, yung weight mo, tsaka yung pag-move down or pag-move back sa datum line natin is same, pa-downward din siya. Yung movement niya papuntang datum is pa-downward, tas pa-downward din yung weight mo. Then therefore, your potential or your work will be positive. Therefore, your energy or potential energy, which is your V sub G, or gravitational potential energy, V sub G, will also be positive. Kasi positive yung Y mo, tsaka positive din yung work mo. Then, yun nga, negative na yung kung nasa ibaba yung object or particle natin, okay, below the datum line. Kasi nga, opposite yung weight tsaka yung pag-move back sa datum line, which is pa-upward. Okay? While at the datum or reference line, kung nandun siya talaga sa datum line, yung gravitational potential energy niya is zero or wala siyang gravitational potential energy. Yun nga. So, magdedepende yung potential energy sa reference line natin. Okay? Pero meron din naman yung i-mention sa problem. Okay? So, kailangan din natin yung i-account if we are going to find the gravitational potential energy. Okay? So, in general, if y is positive upward, the gravitational potential energy of the particle of weight is eto. So, V sub J or gravitational potential energy is equals to the weight times the displacement or y or its position. Okay? So that's how you solve for gravitational and potential energy. Although same lang din dito so, pero nga. Work of the weight times y. So note that the weight is assumed to be constant for small differences in elevation, delta y. So however, for higher differences in elevation, the weight W varies since it is dependent on the gravitational acceleration G and it must be taken into account. Kasi nga, if mas higher na siya sa elevation, mag-change din yung acceleration due to gravity mo. Okay? Kasi meron din certain distance or height papuntang ground. So, iibad na kasi yung gravitational acceleration or acceleration due to gravity. Okay? Sa elevation niya. Okay? So, mag-change siya. So, dapat we need to take that into account if you're going to perform some experiments, no? Kailangan mo din i-consider yung gravity mo sa each elevation or differences in elevation. Kasi nga, pabago-bago din yung gravitational acceleration G. Okay? So, that's for gravitational energy. I hope you understand. So, yung the rotational potential energy, parang din siyang work ng weight. Okay? So, elastic potential energy. Okay? So, when you say elastic, so involves spring, no? So, consider a fixed elastic spring with an attached particle or object as shown in the figure. Ito yung spring mo, unstretched position, ito yung elongate or ano tawag dito? Yun nga, elongate tsaka compressed. No? So, yung positive S sa negative S kasi nga sa datum line natin, sa unstretched position natin is, ayun, lumiit. Tapos sa elongation naman is humaba. So, when the elastic spring is elongated or compressed to a distance S from its unstretched position, elastic potential energy V sub E can stored in the spring. Okay? When the elastic spring is elongated or compressed to a distance S from its unstretched position, elastic potential energy V sub E can stored in the spring. So, okay? So kung hindi pa siya stretch or kinompressed, wala siyang potential or elastic potential energy. Magkakaroon lang siya pag binago mo or in-stretch mo or kinocompress mo. Okay? Magkakaroon na siya ng elastic potential energy. Pero hindi mo ginalaw, edi wala yung potential energy. Okay? So, this energy can be computed using the formula. Ayun. So, V sub E is equals to a half of K times S squared. Okay? So, this is your how you compute o kung tatanungin mo yung sarili mo, ano kayang elastic potential energy ng spring na yan. Okay? So, you need to stretch that out or compress that out para malaman mo. Okay? Kung gusto mong malaman yung na-store na elastic potential energy sa spring mo, okay? Kunin mo lang yung in-stretch na distance mo or kinompress na distance mo away from its initial na unstretched position. Tapos alam mo na yung constant stiff or coefficient of stiffness ng spring mo, then you can have your elastic potential energy na na-store mo when you stretch or compress that spring out. Okay? So that's how you solve for potential energy sa elastic or sa spring. So in equation 7.5.2, it is always positive. Since in the deformed position, the force of the spring has the capacity or potential for always doing positive work on the particle when the spring is returned to its unstretched position. Ayun. So, kumbaga, let's say, inelongate mo or in-stretch mo yun, So, when you release that one, babalik siya sa unstretched position niya. Which is, papunta, ito. Okay? If we, focus muna tayo sa in-stretch niya. Okay? So, obviously, magiging mahaba to. So, when you release that one, ayun, so, yung may force siya na papuntang datum line, no? Or pa left side. And then, yung din niya, yung away from the datum line, yung distance siya from the datum line is same thing with the positive work, no? So, that will be your, the position or the deformed position, the force of the spring has the capacity or the potential for always doing positive work on the particle when the spring is returned to its unstretched position. Okay? So, ayun lang. Potential, kung may siyang potential na or capacity, no, na always siya magdudo ng positive work. Okay? Kasi nga, when you unstretch that one or when you release that one, no, babalik siya sa unstretched position niya. Okay? Pa-compress man siya or elongate. So, always positive yung elastic potential energy. Okay? So, that's your elastic potential energy. Okay? So, potential function. So, if a particle shown in the figure is subjected to both gravitational and elastic forces, the particle's potential energy can be expressed as a potential function, which is the algebraic sum of the two. Okay? Potential function V is equals to V sub G plus V sub E. Okay? Sum lang ng dalawa. Yung gravitational potential energy plus elastic potential energy. Okay? So, in equation 7.5.3, V depends on the location of the particle with respect to a selected datum or reference line in accordance with the equation 7.1, 7.5.1, and 7.5.2. Okay, that's your 7.1 is the formula of getting your gravitational potential energy, and your 7.5.2 is the formula to determine your elastic elastic potential energy. Okay? So the work done by a conservative force in moving the particle or body from one point to another point is measured by the difference of 7.5.3. That is this one. Okay? So makukuha mo yung work done ng mga conservative forces mo by getting the difference of the position if it's initial tsaka final position mo. But here, it should be the potential function na. Yung sum ng dalawa, okay? So that will be your work done by a conservative force is equals to V sub 1 minus V sub 2, which is your V sub 1 is equals to V sub G sub 1 plus V sub E sub 1 minus V sub G sub 2 plus V sub E sub 2. Okay? Wag kayo ma-confuse. Okay? So this is V sub 1. This is the sum of the two gravitational tsaka elastic, ha? Yung meron kasi silang initial tsaka final position, okay? So it should be V sub 1 minus V sub 2. Huwag kayong malito, ha, baka malagay nyo dito V sub 2 minus V sub 1, which is not correct. Pagbaliktad sila dito, V sub 1 minus V sub 2. Okay, negative always yung final position mo. Okay? So for instance, as shown in the figure, the potential function for a particle of weight W suspended from a spring can be expressed in terms of its position, measured from the datum located at the unstretched length of the spring. Okay? So, yung initial mo sa datum, tas in-stretch mo. Okay? So, meron siyang gravitational tsaka elastic na potential energy. So, kailangan mo din i-consider. So, ayun nga, in-express siya in terms of position. Okay? Yung weight tsaka yung elastic spring mo na andyan sa system natin. So, thus the equation 7.5.3 will be this one. Okay? So, that will be V is equals to the formula to get your weight. Now, since it is below the datum line, negative yung potential energy ng gravitational. Okay? Na-discuss na natin yan. Bakit? Okay? So, negative W S plus 1 half KS squared. Okay? Kasi always positive yung natin dito, di ba? Yung V sub E natin. Okay? Yeah. So, 1 half KS squared. Okay? Weight, W is negative because it is below the datum. Okay? Miniscuss na natin yan. Bakit? So, if the particle moves from S sub 1 to lower position S sub 2, then applying equation 7.5.5 and substitute it to the equation 7.5.4, we have this is our 7.5.4 na equation, which is U sub 1 to 2 is equals to V sub G sub 1 plus V sub E sub 1 minus V sub G sub 2 plus V sub E sub 2. Okay? So, substitute natin yon. Okay? Yung natin, 7.5.5 na equation sa 7.5.4, which is ito. And then the 7.5.5 is this one. Okay, so to find the gravitational potential energy, it is determined by negative kasi nga below the datum line, W S sub 1 plus 1 half KS squared, KS sub 1 squared minus times negative W S sub 2 plus 1 half KS sub 2 squared. Okay, that will be U sub 1 to 2 is equals to negative W S sub 1 plus 1 half K S sub 1 squared plus 1 half, W S sub 2 minus 1 half K S sub 2 squared. Kasi nga, didistribute natin each terms yung negative sign. So, with negative times negative, positive. Negative times positive, that will be negative. Therefore, lang natin, rearrange lang natin para hindi tayo mamaya when we are going to simplify this one. So, ginote natin or ni-arrange natin according to its potential energy. So, sa gravitational, ito yung dalawa, initial tsaka final. and then ito din yung elastic. Therefore, your work, no, sa potential function is equals to the weight, weight yan, times s sub 2 minus s sub 1 minus 1 half k times s sub 2 squared minus s sub 1 squared. So this is how you solve for your work of the conservative forces na andyan dito. Okay, andyan dito. Okay, that's your work done by the conservative forces. That will be W, or the weight, times the displacement from the initial tsaka final position. Okay, s sub 2 minus s sub 1 minus 1 half k times s sub 2 squared plus minus s sub 1 squared. So when the displacement along the path is infinitesimal, for instance, from point xyz to x plus dx, y plus dy, and z plus dz. Kasi nga, yung change of position niya is infinitesimal lang. So we just have to add a dx for x, dy for y, and dz for z. Kasi nga, infinitesimal yung change ng position natin or displacement. Okay? So, and nga, to solve for the work from 1 to 2, that will be v1 plus v sub 2. No, this is minus class. Okay, change lang natin para hindi kayo malito. This is negative. Minus yan, minus. Not positive. Okay? Minus yan. So, v times, or du is equals to v of xyz minus v of x plus dx plus y dy plus dz. So, du is equals to negative dv xyz. Okay? So, this is your du na. So, okay? So, it's equals to negative dv x, y, z. Okay? So, if we represent both force and its displacement as Cartesian vector, then the work can be also expressed as 1. So, ayun nga, du is equals to f dot dr. We all know this one. So, where f is equals to f sub xi plus f sub yj plus f sub zk, and therefore r is xi plus yj plus zk. Okay, du is equals to, ayun na, in terms of its Cartesian vectors. Okay, so f sub xi plus f sub yj plus f sub zk dot f dxi plus dyj plus dzk. Okay. So, from this one, ano lang natin, multiply na natin mga fx times I, that would be 0. So, dxy, so that will be fy dy na lang siya. So, sa matitira na dito, when we dot product these two terms, will be this one, fx dx plus fy dy plus fz dz. Substitute lang natin sa equation natin kanina and expressing the differential dv xyz in terms of partial derivatives. Okay, partial derivatives natin dito So that will be your du is equals to negative dv xyz. Okay, so partial derivative ng dv natin, that will be partial derivative v to x dx. Ayan. So, ito na yung final, yung du mo is equals f x dx plus f sub y dy plus f sub z dz. Okay? Tapos yung difference mo dito is we express in terms of partial derivatives. So, ayan. Since changes in x, y, and z are all independent of one another, this equation provide, ayan, f sub x is equals to negative, okay, partial derivative v x, no, yan. Same thing with the y and z. So, substitute lang natin. That would be, yun. So, yung f sub x will be this one. F sub y will be this one. And then also this one. Okay. So, equal silang dalawa. Okay? Equal or satisfied. Same kasi kasi nga, f sub x, we say that it is equals to negative. Ayun, negative siya. So, same lang yung dalawa, no? Thus, ayun. Sinatisfy lang natin na equal silang dalawa. So, that will be f is equals to negative, partial derivative b, I, j, and k. So, same thing lang din yung dalawa. Okay, so i-shrunk yung negative v. So matitira na lang dito is, ayun, partial derivative, ito. So therefore, your f is equals to negative, ano to, pabektoran ng delta, that will be your del. Okay? So that will be del is equals to the vector operator. So ito is the vector operator lang, okay? So your del. Okay, so equation 7.5.8 relates a force F to its potential function V. And that F is a conservative force. Okay. So for instance, the gravitational potential function for a weight located a distance y above the atom is V sub g that is equals to Wy. So substituting it to y component of a force, we have ayun. So magiging ganito na siya. Okay? Kasi nga potential energy of or the gravitational potential energy function, ayun, i-substitute lang natin yung V sub g was equals to Wy. So magiging ganyan siya. So sinatisfy lang natin dito na equal talaga yung yung weight mo when we trying to its potential function will be magi-cancel out kasi ito siya, okay? So that will be delta of delta or the partial derivative of Wy will be equal to f sub y is equals to negative weight if we are talking about gravitational potential function. So may iba din ito when we are talking about another potential function. Okay? For the weight, ito yung mangyayari sa kanya. So f sub y is equals to negative w na lang. Okay? So the negative side indicates that w acts downward opposite to positive y, which is upward. Okay? Ayan nga, dito sa ano natin. Yung weight mo is pa downward but your displacement is pa upward. Okay? So that's how you analyze the potential function. Okay? So let's go to conservation of energy. I think meron na kayong thoughts dito. So conservation of energy is when a particle or a body is acted upon by a system or both conservative and non-conservative forces. The portion of the work done by the conservative forces can be written in terms of difference in their potential energies using ito. Okay? So, conservative or work, okay, summation of all the work done by all the forces or conservative forces equals to V sub 1 minus V sub 2. Okay? Alam natin to. So as a result, the principle of work and energy can be determined using this one. Okay? This is based on the principle of work and energy na discuss natin sa lesson 7, okay? Which is the sum of the initial and the summation of all the work done by all the forces equals to the final kinetic energy, di ba? Ito yung principle of work natin. So, since dalawang forces yung kinonsider natin, yung conservative tsaka yung non-conservative forces, dapat i-account din natin yung mga work done nila. So, meron tayong sa conservative forces and also with the non-conservative forces. So, i-account natin yung dalawa and solve by lahat ng work done ng dalawang forces, i-add lang natin sa initial kinetic energy, makukuha natin yung final kinetic energy. Okay? So, substituting, we have, ayun. So, conservative forces, alam natin to kanina, na-discuss natin sa potential function na yung summation of all the work done by the conservative forces equals to V sub 1 minus V sub 2, which is the potential function, initial potential function minus the final potential function, which is yung V sub 1 natin is summation ng dalawa, di ba? Yung potential energy ng gravity or gravitational tsaka potential energy ng elastic, no? So that would be T sub 1 plus V sub 1 minus V sub 2 plus summation of all the work of the non-conservative is equals to T sub 2. Okay? So i-transfer lang natin yung potential function sa yung negative V sub 2 sa right side. So that will be T sub 2 plus V sub 2. So okay? So note that summation of all the work done by the non-conservative forces represents the work of the non-conservative forces acting on the particle or body. So mga non-conservative forces natin like friction force, yung force na in-apply, o mga external forces na in-apply ng object natin. So mga ganon. Okay? Na nagdedepende sa path ng displacement. Okay? Or the movement or the motion of the body. Okay? That's your non-conservative forces. So if only the conservative forces do work, then we have mawawala na tong non-conservative natin. Kasi the conservative forces lang ang nag-work. Di ba? So, mawawala tong non-conservative natin. So, equals to 0. So, matitira na lang is your t sub 1 plus v sub 1 is equals to t sub 2 plus v sub 2. So, equation 7.6.2 is referred to as the conservation of mechanical energy or conservation of energy. So, in-account na natin dito is if only the conservative force is only doing work. Okay? So, hindi natin in-account yung non-conservative kasi kung i-apply na natin, if kukunin natin yung non-conservative, magiging non-conservation of energy natin to kasi meron non-conservative eh. Pero consider na natin yung conservative, kaya tinawag siyang conservation of energy kasi conservative forces lang yung nagdo-do work. So, para siyang walang exertion sa mga external forces tsaka yung mga non-conservative, which is hindi independent sa path ng ng object natin. So, ayun. So, when we say conservation of energy, only the conservative forces doing work. Okay? So, ito yung formula mo for your conservation of energy. T1 o T sub 1 plus V sub 1 is equals to T sub 2 plus V sub 2. So, it states that during the motion, the sum of the particle's kinetic and potential energies remain constant. Okay? So, in other words, yung initial na energy is equals to the final. So, walang na-waste, walang na sumobra, or walang kumulang. So, kung ano yung initial na mga kinetic tsaka potential energy mo, same lang din sa final. So, walang change. Okay? Walang pagbabago. Okay? So, again, the conservation of energy during this motion or during the motion of conservation of energy, the sum of the particles kinetic V, P is equals and potential energy V remain constant all throughout the motion. Okay? So that's your conservation of energy. For example, so if a ball of weight W shown in the figure is dropped from a height h above the ground, ayun, so above the ground natin, yung datum natin is the ground its maximum potential energy is located at the height h or height before it is dropped. No? At which time its kinetic energy is 0 kasi at rest pa to siya eh. So sa pinaka taas, no? Kasi dinrap eh. So yung height niya pag drop, yun yung maximum height niya. Kasi hindi naman dilipad yung ball mo kasi meron tayong gravity. Okay? So, yung pag-drop mo above the ground, that will be your maximum height. And your potential energy or gravitational potential energy is, it depends on the position, no? The height of the, ang tawag doon, sa ball mo. So, masasabi natin yung pinakamalaking potential energy na kayang mas store ng ball mo is andun sa pinakamataas na height sa pag-drop ng ball mo. So, sinabi dito, yung potential energy is at maximum, tsaka yung kinetic energy mo, since at rest sa pag-drop mo, hindi pa siya nag-move prior to dropping, no? So, wala siyang velocity, therefore wala siyang kinetic energy. Okay? So, sinabi dito, kinetic energy is zero. But the potential energy is at maximum. Okay? Okay, so maximum potential and energy is located at the height h, or the height before it is dropped, at which time the kinetic energy is zero. Okay? So that's the potential, that's the total mechanical energy E of the ball in its initial position is ito. Okay? So for the energy or mechanical energy at initial position, E, kaya E lang siya. So the total mechanical energy is the sum of the two, the potential tsaka yung kinetic, no? Sum ng kinetic tsaka potential, ito yung total mechanical energy mo sa bola mo. Okay, which is equal to 0 plus WH. So therefore, your total mechanical energy is equal lang sa potential energy ng bola mo. Okay? So that's for initial position ha. So your E is equal to WH lamang. Okay? That's where your total mechanical energy, which is your weight times the height, that's your mechanical energy. So when the ball when the ball has fallen a distance of h over 2, or the half of the drop distance, its the speed can be determined by using sa kinematic, no? Kinematic equation. So v squared is equals to v sub o squared plus 2ac y minus y sub o. Okay, so v sub o is 0, a sub c is g because it is a free falling body. So y is equals to h over 2 and y sub o is initial position is 0. Okay? So yung v squared is equals to 0 since at rest, squared plus 2g minus times h sub 2 o h over 2 minus 0. So ito yung matitira mo, gh or square root of gh, so that you can have your v. Okay? So that will be v is equals to square root of gh. Ito yung velocity mo, half fallen na. Okay? Half na sa distance na pag-drop mo. Okay? Ito yung velocity mo. Therefore, getting for the kinetic energy, or thus the energy E of the ball at the mid-height position is this one. Okay? So 1/2 mv squared for the kinetic plus the potential, ito yun. Okay? So 1/2, solving for the mass is weight over g. That's for your mass, W over g, which is weight over the gravitational acceleration, times the velocity na na-compute natin kanina, which is square root of gh. Now, this is your velocity sa kalagitnaan, no? Ito yung square root of gh. Square that one kasi yun yung formula ng kinetic energy. Plus, for the potential, weight times h over 2. Okay? So, your E now is equal to 1/2 of W over G, GH, na-cancel out yung square sa square mo, 1/2 WH, okay? So, W over G times G is makakancel out tong G na to. So, matitira din to is 1/2 WH plus 1/2 of WH. And therefore, E is equal to WH pa din. Okay? Same thing sa initially, no? Initial niya na Kasi yung nasa top pa lang or before pa ni-release yung natin, yung bola natin, yung energy or total mechanical energy is WH. Now kung nasa gitna na yung bola, same pa rin yung energy na nandun sa bola natin, which is WH. Same thing with at the top sa di ba? Okay, so A is equals to WH. Okay, lastly, just before the ball strikes the ground, its potential energy is 0 and its speed is V is equals to square root of 2GH. Okay? Hindi na kailangan natin to kung saan ba to kinuha o paano ba to kinuha. Basta kayong V squared is equals to V sub O squared plus 1/2 G. Yeah, Y minus Y sub O. Okay? So, that's the formula. Now, given na yung YO or Y final position mo is 0, kasi nga wala na siyang dito, or H pala, okay, that the final Y or position is H, tas yung initial mo is andun sa 0, so makukuha mo tong so V squared is equals to 2GH lang. Tapos, kukunin mo yung V, that will be square root of 2GH. Okay? So, ito yung velocity niya, when the ball strikes the ground. So, its potential energy is 0, and its speed is, square root of 2GH. So, wala na siyang height when the ball strikes the ground. So, wala din siyang potential energy. Therefore, the total energy of the ball would be T sub 3, or the position 3, or the third position T, or the third position, or the kinetic energy at the third position of the ball plus potential energy at the third position of the ball, 1/2 mv squared plus 0. Tapos, to compute for the mass again is W over G times the velocity squared. That will be 2GH squared, no? Square root of 2GH squared. So that will be 1/2 WG 2GH. So makakancel out tong 2, tsaka 2, makakancel out din yung G, tsaka yung G. Therefore, yung E will be W times H, which is equal lang din sa initial na position niya. Okay? Same yung energy dito. Energy sa 1, okay? Yung energy 1 mo dito, equal lang sa energy 2 mo dito. Diba? Same lang din. Tapos, same lang din sa energy mo or total mechanical energy ng bola mo at the third position. Okay? So, therefore, conservation of energy is there. Okay? Kasi nga, initial position of the ball and the final position of the ball has the same mechanical energy or energy. So, yun, conservation of energy talaga yung nangyayari when a ball is free falling na. Okay? Same lang yung energy at the top and when the ball strikes the ground. Okay? So, that's your conservation of energy. Example, so in application lang, no? Kung totoo ba talaga to. And we did some calculation to prove this one. And yeah, we did discover na, totoo nga, na yung conservation energy is really happening, no? Okay? So that's your conservation of energy. So system of particles. If a system of particles is subjected only to conservative forces, then the kinetic energy and potential energy can be determined the equation this one. So summation lang lahat ng system ng particles mo. Sum mo lang lahat. So you can solve for your kinetic and potential energy, no? Or conservation of energy pa rin sa system of particles. So the equation above states that the sum of the system's initial and kinetic potential and some initial kinetic and potential energy is equal to the sum of the system's final kinetic and potential energies. So another conservation of energy, but yung yung system of particles na. Okay, summation mo lang. Yun lang yung nagbago. Or simply, summation of T is equals to summation of V constant. Yun. Okay? So, procedure for analysis and key points. So, conservation of energy equation can be used to solve problems involving velocity, displacement, and conservative force systems. So, potential energy. Identify the given and announce the required of the problem. Draw the two diagrams showing the particles located at its initial and final position along the path. If the particle is subjected to a vertical displacement, establish the fixed horizontal datum or reference line from which to measure the particle's gravitational potential energy. So, need talaga ng vertical displacement niya, no? So, establish the fixed horizontal datum or reference line. Ayun. So, you need to establish fixed horizontal datum or reference line. So, always dapat natin i-establish yung reference line niya, no? To measure the particle's gravitational potential energy or V sub G. Okay? For spring naman, to solve the potential energy in which result is always positive, use the formula. Alam natin to, 1/2 of K squared And conservation of energy, apply na natin to kasi nga we have already computed the gravitational potential energy, then we can solve for the kung ano yung mga unknowns na andito. Okay, where T is equal to 1/2 of mv squared. Okay, let's have an example para ma-apply din naman natin yung mga ano natin na more importantly is yung conservation of energy. Okay, so the gantry structure shown in the photo below, of the photo beside the picture or beside the question, is used to test the response of an airplane during a crash. So, as shown in the figure, okay, the plane having a mass of 8 megagrams is hoisted back until theta is equal to 60 degrees. And then pullback cable AC is released when the plane is at rest. Determine the speed of the plane just before it crashes into the ground. Theta is equal to 15 degrees. Also, what is the maximum tension and developed in the supporting cable during the motion? Neglect the size of the airplane and effect of the lift caused by the wings during the motion. Okay, so determine na natin yung excuse me, speed ng plane tsaka yung maximum tension. Okay, so this is your given. Tayong dito, length of the tension wire, and you have your AC, you have your airplane, and the position A and position B, and we have your angle. Okay, so mass of the plane is 8 megagrams. Theta, initial position, is 60 degrees, and the final is 15 degrees. And the required is the speed of the plane just before it crashes the ground and the maximum tension developed in the supporting cable. So, first tapos na natin nag-identify ng mga given tsaka unknowns. Next is to draw the free body diagram to show the forces acting on the plane. Okay, ito yung FBD natin. So we have your tension of the wire or the cable, tas yung weight ng plane mo. So note that the force of the cable doesn't work because it is perpendicular to the plane's path, no? So indicated that the datum line is reference in this problem. It has already indicated, no? Kasi nga, yun yung datum line natin, yung before it release or at rest pa yung natin. So doon din yung natin, reference line. Okay? So solve the speed of the plane at B by applying conservation energy formula. Okay? So solve natin to. So 1/2 m sub P V sub A squared. Yun yung mga initial nila. Minus W sub P or the weight of the plane times H then cosine theta. Initial, no? Is equals to 1/2 m sub P V sub P squared minus W sub P H cosine theta. Note that V sub A is 0 since it is initially at rest at 60 degrees. Okay? So, compute natin. So, 1/2, 8 megagrams, ito yung mass, times 0 kasi nga at rest, minus yung potential energy niya, initially, so 8 megagrams, 100 kilograms, kinonvert natin yung megagrams to kilograms para man-Newton siya when we are going to multiply that by the acceleration due to gravity, which is 9.81 meters per second squared, times 20 meters, so this is your height, no? Cosine 60. This is your etong datum line natin. Kasi ito yung datum line natin dito dito. Okay? So ano yung distance niya from the datum line at this one. So to find this adjacent side of the plane dito. Ito yung delta 60 mo. So for this distance, cosine theta natin. Okay? So that will be cosine 60. And for the final naman, we have 1/2. And ito yung natin kasi before it crashes, diba? So ito yung final position niya. Or final velocity, rather. Okay? So 1/2, 8 megagrams. Convert natin to kilograms. Times B sub G squared. B sub V squared minus 8 megagrams. Times 1,000 kilograms over 1 megagrams. Times 9.81 times 20 cosine 15 degrees. Okay? Ito na yung final position niya. ng ano natin, o ano na ba yung distance from the datum line. So, when it crashes, okay? So, that will be 0, yun, 0 to, minus, ito is 784,800 joules. Okay? So, it is equal to 4,000 vis-a-vis squared. Yun. So, that will be your and 1/2 of the megagrams, that will be 4,000 kilograms. No? Minus, yung potential energy mo, okay? Potential energy when before it crashes, that will be 8 megagrams times ito. So, that will be your 1,516,117.177 joules. Solving for your V, ayan. For your V is 13.52 meters per second. So, yung medyo simple lang no? Kasi consider mo lang yung mga ano mo. So, yung nagbago lang dito is mas tricky dito is yung mga position na ano natin. Yung datum line talaga. Medyo tricky yung datum line natin or reference line. But if it indicates naman sa problem na dun yung datum line mo, then no problem. Substitute mo lang yung mga ano natin, mga given, then you can have our velocity of the plane before it crashes. Okay. So that's your velocity. How about for the tension, no? So as shown in the FBD, apply the equation of motion with respect to the normal component. Okay. With respect to the normal component, that will be summation of all the forces normal component is equals to the mass times the normal component of the acceleration. Okay. That will be your tension of the wire minus W cosine 15. Kasi nga, ito yung ano niya is if you okay dito, okay, so to solve for the a component of the weight na in line with the normal component, that would be weight times cosine 15. Ito, okay, is equals to the mass times v squared over rho. Okay, that's how you solve for the normal acceleration, diba? Normal component of the acceleration sa natin sa planar kinematics. So that will be v squared over rho. So that will be T is equals to 8,000 kilograms times 13.52 meters per second times the radius or the rho or 20 meters plus 8,000 kilograms times 9.81 times cosine 15. Therefore, your tension will be equal to 148.92 kilonewton. Okay? So that's how you solve for your tension. Okay. So, ayun. Importante dito is your yung diagram mo when you're showing the datum line. Okay? Tsaka yung FBD mo ng plane. Okay? So, to solve for the tension. So, that's how you solve for this problem. Na-relate natin yung conservation of energy tsaka yung equations of motion. Okay? So, let's have another example. So, the ram R, shown in the figure below, has a mass of 100 kilograms and is released from rest 0.75 meters from the top of the spring. Okay? So, that's spring A. Okay? A yung spring natin. That has a stiffness, K sub A, is equals to 12 kilonewton per meter. If second spring B having a stiffness K sub B is equals to 15 kilonewton per meter is nested in A, determine the maximum displacement of A, okay, needed to stop the downward motion of the ram. The unstretched length of each spring is indicated in the figure. Neglect the mass of the spring. So, ang kailangan natin is the displacement or the distance na kailangan ng A para ma-stop yung downward motion ng ram natin. Kasi it will fall down here. So, spring natin. So, let's solve that one. Okay. So, this is your given. The mass of the ram is 100 kilograms. The stiffness of the two spring, A, 12 kilonewton per meter for A and 15 kilonewton per meter for B. And the required is the maximum displacement of A needed to stop the downward motion of the ram S sub A. Okay? Ano ba kailangan natin gawin? So, we will assume that the ram compresses both springs at the instant it comes to rest. Okay? So, draw a diagram showing the initial position of the ram and its position when it's compressed. Okay? So, kailangan natin ng datum line again. So, when it was at rest before it release, no? Or before it fall down, meron tayong datum line dito. And when it stopped, meron din tayo dito. Okay? So, from the diagram, indicate the datum or reference line. In this case, it is located through the center of the gravity of the ram at its final position. Okay? When the kinetic energy is reduced to 0, V sub 2, at final position, A is compressed at a distance S sub A. Ayun. So, na-displace siya or na-compress siya at that distance S sub A. And B compresses. S sub B is equal to S sub A is minus 0.1. Kasi ito yung distance niya from the A tsaka yung B. Kasi nga, 0.4 yung distance ng spring A natin from the ground. Tsaka distance naman ng unstretched distance or unstretched length ng spring B natin is 0.3. Therefore, their difference of their elevations from the ground is 0.1, no? Therefore, yung pagkuha natin sa spring or the compressed distance ng spring B natin is S sub A minus 0.1 meter. Yun lang, no? As shown in the diagram. Ayun. So, then applying conservation of energy equation, ito, okay? So, T sub 1 plus V sub 1 is equal to T sub 2 plus V sub E sub 2. So that will be 1/2 mv sub 1 squared plus V sub G sub 1 minus V sub E sub 1. And na dito, kailangan natin i-consider of course yung spring kasi meron na siyang elastic potential. Kailangan na natin i-consider yung elastic potential energy kasi meron na tayong spring involved, no? So it is equals to 1/2 or the final energy 1/2 mv sub 2 squared plus V sub G sub 2 minus V sub E sub 2. Okay? So that will be the initial velocity is 0. Okay? So weight at the height of this one is 0. Okay? So 1/2 0 pa din siya kasi hindi pa siya na-stretch initially yung natin. So 0 din yung potential energy ng spring natin kasi it wasn't compress or stretch, no? 1/2 na times the final is 0 din kasi stop din siya. Kasi ang final natin, condition is nag-rest yung ram natin at the final kasi nga stop Kailangan ding i-consider yung stoppage ng ng ram natin because of the spring, no? Plus the 1/2, okay? K sub A times A sub A squared plus 1/2 of K sub B squared kasi dalawang spring to Okay? So dalawang spring siya kasi dalawang spring yung non-stretch minus weight times height. Okay? So yung mga naging 0, bakit siya naging 0? Initially, it was at rest. Yung ram natin, so wala siyang kinetic energy initially. Now for the potential energy naman or gravitational potential energy ng ram natin, since nasa datum siya initially, wala din siyang height, no? Wala din siyang displacement, so 0 din siya. Now for the initial yung initial spring natin, since it was unstretched, no? Hindi siya ginalaw, then therefore wala siya potential energy as well, di ba? Kasi hindi siya ginalaw yung spring natin, so ano ba yung energy? So wala nung hindi mo siya ginalaw, so that will be 0 also. Now for the final, yung kinetic energy natin sa final position, we consider na yung ram natin is na-stop na siya on moving, no? Di ba? To stop the movement, no? Downward movement of the ram. So yung velocity natin for the final position of the ram is 0 kasi nga nag-stop siya. Na dapat na lang natin consider dito is the spring or the potential or elastic potential energy of the spring A, the elastic potential energy of the spring B, ayun, and the potential or gravitational potential energy of the ram. Okay? So, eto lang yung matitira. Yung sa spring tsaka yung sa elastic tsaka yung gravitational. So, substitute lang natin yung mga given and may iwan dito is sub A. Ano ba yung dinisplace ng A natin? No? That will be S sub A, di ba? So, that will be 1/2 times 12 kilonewton. Ito yung K, stiffness. Convert na natin to Newton para ma-uniform yung formula natin o ng units natin times S sub A squared. Ito yung natin final position ng A natin kasi ito yung displaced ng spring natin when the ram is in contact with the spring, and yun nga, mabigat yung ram, then expected natin na mako-compress yung spring natin. So ito yung na-compress na length because of the downward movement of the ng ram, plus 1/2 ng spring B natin, that will be 15 kilonewton yung stiffness ng B, times, convert na natin to Newton, times, now the displacement of the A, or the B, rather, the displacement or the compressed length of the B is equals to the SA, or the length of that A, minus 0.1. Okay? Square that one. So, that's your displaced or the compressed length of the B. Diba? Kasi nga, ang distance between nila is 0.1 kanina, diba? So that will be S sub A minus 0.1 squared minus 100 kilograms. That's your mass times the gravitational acceleration, so that we can get the weight, times the displaced length or the displaced height ng ram natin, kasi yung datum line natin is 0.75, diba, yung length ng natin, distance sa spring kanina. So that will be 100 kilograms times 9.81 meters per second squared times 0.75. Therefore, solving for your S sub A using quadratic equation or using your calculator where your A is 13,500, your B is negative 2481, and your C is negative 660. And then shift solve mo lang doon. Thus, roots are eto. So, S sub A sub 1 is 0.331 meters and S sub A sub 2 is equals to negative 0.148 meter. Select the positive root, no? Therefore, your S sub A or the compressed length na kayang i-stop ng spring yung weight or downward movement ng ram natin is at a distance of 0.33 from its original or unstretched length. So that will be 0.33 meters. So that's how you solve your length or the distance or the compressed length of the S sub A so that it can stop the downward movement of the ram. Okay? So I think that's all for this video, and I hope you did learn something from this one. No? So for the summary, to summarize now, so we discussed about the power, no? Which is equals to so F times velocity or work over time. We also discussed about the efficiency, which is equals to output over input times 100. That's your efficiency. And we also discussed about the two energy, no? You have your potential tsaka kinetic. And we all know the kinetic is 1/2 mv squared. And for the potential naman is WH. Meron din tayong tinatawag na mga potential energy, no? Sa gravitational, due to gravity, tsaka yung spring, no? For the gravitational, meron tayong WH. That's so for the energy or the gravitational potential energy. And for the elastic naman is 1/2 Ks squared, which is always positive, no? Kasi positive yung ano niya, work na doon to cause energy. Okay? And we have also the potential function, which is your V, which is equals to the sum of the gravitational tsaka yung elastic mo, di ba? Okay? And for the potential energy, oh no, the conservation of energy states that the energy or the total energy at the initial is equals to the final total energies, no? Which is, ano lang, yung constant lang yung walang changes na nangyayari. That's your kinetic energy, which is equals to T sub 1 plus V sub 1, no? Is equals to T sub 2 plus V sub 2. With considering that only the conservative forces are doing work. Okay? So that's your conservation of energy. And I hope you did learn something from this video. And up next will be your planar kinetics of rigid body, work, and energy part 1. So, ano naman yung mga planar kinetics na natin doon. So, that will be your lesson 8. Well, I hope you did learn something again, and thank you for listening.